Now the topic is divergent of vector field. So what is divergent? Divergence physically of a vector field at any point is defined as the net outflow or flux of that field per unit volume, and it symbolically divergence A, where A is a vector, equals to del operator dot A vector, where del operator equals to, we know, I del x plus j cap del y plus k cap del z, and we have taken A equals to I cap ax plus j cap ay plus k cap az. So divergence A equals to del dot A means I del x plus j del y plus k del z dot product I ax plus j ay plus k az. So simply I dot I equals to 1, I dot j 0, and I dot k also 0. So remaining term only first term. So this gives del ax del x. For second case, j dot I equals to 0, j dot j equals to 1, j dot k equals to 0. So just dot remaining dot product is j dot j, that is del ay del y. And for the third case, similarly, k dot k equals to 1 and del, this gives del az by del z. So this is the divergence of A, any vector field. Now we are going to discuss about the physical meaning of divergence. So physical meaning of divergent. We know in the first that divergence means the spreading out or net outflow or flux of that field per unit volume. So del dot A measure of how much the vector spread out, of how much, this is important, how much vector is spreads out. Let us example that a point source, there will be a vector field spreading outward direction. So this type of spreading indicates that a vector has a divergent property, and obviously this is a positive divergent. If there will be a source or there will be a point and the vector field direction is along this, means inward to the point from all direction, so we can say it as a converging field or negative divergent. We can imagine also a few parallel electric or magnetic field line This type of vector field line has a gradient, divergent 0. So this is called 0 divergent. And secondly is, and these three has a defined category. This is a positive divergence. It also known as source field. Means A is a source field. For this case, A is called sink field, means absorbing sink field, and for this case A is called solenoidal field. As an example, del dot B equals to 0, so B is a solenoidal field. Now we are going to solve a problem. Now we are going to solve a example with divergent, means how to calculate the divergence of. Let f field vector equals to 2x square z I minus x y square z j plus 3yz square k. We have to find out the divergent of f, that is del dot f. So how to get? So just put the value of, we can compare, this is ax, this is ay, this is az. So this is ax, this is ay, this is az. So del dot f equals to, we know that del f del x, and for this case this would be the ax. For second term this will be, if this is a, then this is del y ay del y plus del az del z. So in this case our a equals to, in this case a equals to f. So and we get del ax means 2x square z del x. This y ay gives ax y square z, that is ax y square z del y plus del az equals to 3yz square, 3yz square del z. So these all are partial derivatives. So for first term take constant y and z, for second term take constant x and z, and for third term constant is x and y. So this gives 2, for x square equals to also 2 into 2x to z. For this case x is constant, for y 2y z plus the 3 is constant, y z square 2z. So finally give 4xz plus 2axyz plus 6yz. So this is our solution. So it is very easy. Thank you for this class.